Dear fourth year students, how are you? I think you are staying safe at home and following all the instructions set by the government. So I welcome you to join my class. I used to take the course, Methods of Applied Mathematics of fourth year honors. So today I will be discussing on the course titled Method of Applied Mathematics, which is Methods of Applied Mathematics. You know, mathematics in higher study has two branches. One is pure and another one is applied. So applied mathematics, which is highly science oriented, especially physics oriented side of mathematics. Uh, so we will be talking about methods of applied mathematics. Firstly, books recommendation. I suggest uh, or I recommend you to follow the book Methods of Applied Mathematics by Professor Abu Yusuf. Uh, this book is very useful and very conceptual or textbook, come um, made easy type uh, book, so it will be very useful to use for you. This book is available in our departmental seminar. You may easily collect or buy a new one from market. So let us talk about methods of applied mathematics today. Uh, Today I will talk about Fourier series. See, we learn uh, what is called a Fourier series today. The infinite series of the form summation n is equal to 1 infinity a n cos nx plus summation n is equal to 1 up to infinity bn sin nx is called trigonometric series. Series uh, where a naught and bn are the constants. So Fourier series is a kind of an infinite trigonometric series which is represented by this term, which is a naught by 2 plus infinity uh, summation n is equal to 1 from infinity an cos nx plus summation n is equal to 1 to infinity bn sin nx is called a trigonometric series. where A0, An, Bn are the constants here. So this kind of series, this kind of infinite trigonometric series is called a Fourier series. Here A0, An, Bn are the Fourier constants or simply constant. So now we will be discussing about periodic function. Firstly, periodic function. Definition says if fx plus t is equal to fx, then fx is called periodic function. And t is the period. So this is what, uh, for example, uh, for example, the period of sin x and cos x is twice pi, and also the period of tan x is pi, because we know since sin twice pi plus x is equal to sin x, cos twice pi plus x is equal to cos x, and tan pi plus x is equal to tan x. Please pay attention to this. I am talking about periodic functions. What is a periodic function? If function x plus t become fx, then fx is called a periodic function, and here t is the period. You know, sin x, cos x, tan x are all kind of uh, all, all kind of trigonometric functions or wave functions are periodic. You know, the period of sin x and cosine x is twice pi. Also, the period of tan x is pi. Since we know sin twice pi plus x is equal to sin x, and cos twice pi plus x is cos x, and also tan pi plus x is equal to tan x. You have to follow this formula. Sin twice pi plus x is equal to sin x. So twice pi is the period of sine and cosine. In case of tan, it is pi. Since tan pi plus x is equal to tan x. So these are the things about periodic function. You have to know about the periodic function, especially the trigonometric functions period, uh, you have to easily find the period of any kind of trigonometric function. So this definition will be useful for you. Now uh, let us talk about what is called a Fourier series. What is called a Fourier series? Uh, series Fourier series as I said to you earlier, let fx be defined in the interval minus pi to pi with period twice pi, uh, which can be expanded in a trigonometric series. That is, fx is equal to n naught by 2 plus summation n is equal to 1 to infinity n cos nx plus bn sin nx. So this is what is a Fourier series. Let fx be defined in the interval. The fx be defined in the interval minus pi to pi with the period twice pi, which can be expanded in the trigonometric series, that is fx is equal to n naught by 2 plus summation n is equal to 1 to infinity an cos nx plus bn sin nx. Here n naught, an, bn are the Fourier constant or simply constant. We have to define a naught here. Here a naught is equal to, where a naught is defined by the integral 1 by pi fx minus pi to pi dx. An is equal to the same thing, 1 by pi minus pi to pi fx cos nx, fx cos nx dx. And finally bn is equal to 1 by pi minus pi to pi fx sin nx dx. The interval is, see this sketch. This is a curve of sin x. Y is equal to sin x. This is pi and this is minus pi. Here it is pi by 2 and it is minus pi. So the interval is minus pi to pi. Fourier series, the definition is Let fx be defined in the interval minus pi to pi. So the interval is within this uh, range, which is minus pi to pi. Interval minus pi to pi with period twice pi, which can be expanded in a trigonometric series. So this is a trigonometric series. I said to you earlier, fx is equal to n0 by 2 plus summation n is equal to 1 to infinity n cos nx plus bn sin nx. Here n0 is defined. N0 is the Fourier constant, which is defined by this integral 1 by pi minus pi to pi integration minus pi to pi fx dx, and is equal to 1 by pi integration minus pi to pi fx cos nx dx, and third one bn is equal to 1 by pi integration minus pi to pi fx sin nx dx. So these are the Fourier constant. In the next class we will be evaluating this integral. We will be evaluating the value of n0, an, and bn respectively. So these are all about the Fourier series. Today we have talked about the Fourier series, which is an infinite trigonometric series. It has with some constant, which are a0, an, and bn, which are also called the Fourier constant as well. We have also talked about the periodic function, what is called a period of function, about the periodic function, the period of any kind of trigonometric functions as well. So that's all for today. Hopefully we will be discussing further about the Fourier constant, evaluating all the Fourier constant in the next class. So since then, stay safe and sound. In the meantime, you can buy or collect this book, which is Methods of Applied Mathematics by Professor Abu Yusuf. This book is available in our math seminar. Also, you can buy a new copy from the market as well. So start studying closely and follow each and every uh, class conducted by me online. Uh, then surely you will be benefited. Thank you. Stay safe. Thank you.